Hi, welcome back to the Indusoft Web Studio video training series for version 7.1. This is the driver number 2 video. You should have already watched driver number 1 video. In this video, we are going to cover using tags for a station field, main versus standard driver sheets, scanning and scaling, how the priority works and the priority queue for the drivers, virtual read groups, the manual, import wizards, tag integration, and the toolkit. So as we get started, let's talk a little bit about the built-in drivers. I think it was mentioned in the previous video that there's no additional charge for the over 240 built-in drivers that we have included in the product. And it needs to be mentioned that OPC is not required for communications to PLCs. You can use the built-in drivers that we have, but it is in fact optional. In fact, Indusoft is one of the leading implementers of OPC client and server integration into our product. So using the built-in drivers are more efficient, and you should always check our website online for a list of updates. It will show you the driver version in the list of communications drivers that we have, and you can always go online to make sure you have the latest version of the driver and that's updated for your project as you get going. We're going to talk a little bit about main versus standard driver sheets in a moment. Let's flip back here to the Indusoft Web Studio development environment. And what I wanted to point out is here on either the main driver sheet or the standard driver sheet, where you have the station for the IP address for the PLC that you're communicating with, you can in fact use a string tag in here. So by implementing with curly brackets, I could put PLC underscore IP address and close curly brackets, and that tag does not exist. So I can say yes and make sure that that is a string tag, because even though it has numbers in it, it also has points in it between the octets of the IP address and sometimes colons for the port number and the station ID. So it has to be a string type address. And not only that, but here in the main driver sheet, but in the standard driver sheet, you can use that up in this station field as well. So let's talk a little bit about, let's go back to the main versus standard sheets here. I think I covered a little bit of it in driver 1, but we're going to cover it a little bit more detail. The main driver sheet, you can put any address or any tags and I/O address in this worksheet. You can kind of mix and match the different memory types from PLCs and even go to different PLC addresses here. This makes it very easy to configure. But as far as flexibility and what you have control over when it reads and writes, it's not as flexible and powerful as the standard driver sheets. You have these status fields here, but when you get into the standard driver sheets, you have a little bit more triggering functionality here. So let me bring up a sheet here that will discuss the differences between the main and standard driver sheet. So we have the main driver sheet in this column and the standard driver sheet in this column. You can put one main driver sheet. In fact, when you insert a driver into your project, you by default get the main driver sheet. That does not mean that you're required to use it. You can just skip using it altogether and just work with standard driver sheets, or vice versa. You're not required to use either one over the other. You can have anywhere from 1 to 9,999 driver sheets per project. So you can put up to 32,767 addresses in the main driver sheet, and it will figure out and block those up accordingly and optimize the communications. Maximum size, it's really not limited except for this number of rows that you have in here, and this is really determined by the driver. Now this is the block size that the driver will support when reading blocks of addresses at a given time. So you need to pay attention to that depending on how many you can put in there in a row. Enabling the driver worksheet, the main driver worksheet can be enabled or disabled, and the standard driver sheet can be enabled to read when idle. Let me show you a little bit about that. So let's go back into development, go back into the main driver sheet. Using this disable field, I can put a constant, for example 1 in there, and this driver worksheet will be disabled all the time. If I put a tag name in here, whenever this tag name is true, this entire worksheet is turned off. There may be, for flexibility reasons, time when you want to turn this worksheet off and then use standard driver sheets or flex back and forth between the two, or shut your communications down altogether. You could, whatever tag name is here, whenever that value is true, then this driver worksheet will be disabled. In the standard driver sheets, you have these 4 triggering fields, and if none of these are either triggering or set to true over here, then your driver worksheets are not reading, or this particular driver worksheet is not reading. And remember, you can have up to 9,999 different standard driver sheets, so you can determine when they are enabled or disabled just by the tags used in these fields, or constants for that matter. And the default triggering for the main driver sheet is based on the tag called blink slow, and that's approximately 700 millisecond toggle. So that main driver sheet is going to be reading approximately every 600 milliseconds. Now, in the help system, if you take a look, that can be changed to reference a different tag name, so you can alter that scan time. But if you really need to do anything much different than that, then we probably recommend going to a standard driver sheet and creating your own triggers for those. And a couple different ways you can create those triggers. The scheduler worksheet is a very good one for creating triggers that have a time base. You can use down to 100 milliseconds for the time base on the scheduler to create tags for those. Status, you get the 4 different fields that I showed in the previous video. Same with the standard driver sheet. The header file, any supported by the device, you can just put in there, and only 1 per standard driver sheet. Now, what's the difference there? Let's go back and take a look at this. Here, up in the standard driver sheet, we put the header or the memory type. So, for example, for a Modbus, it might be memory type 4, or the holding registers are type 4, or 40,000 type addresses. If we were to communicate with an Allen Bradley PLC, let's say a SLIC or a PLC 5, you might have an N7 up here, and if you had a 0 down here, the combinations of that would be N7:0. Now would be how you would get your addressing. So the standard driver sheets per sheet support 1 memory type, where the main driver sheet you can mix and match and put the different types in here as well. Go back to this chart. The action you can read or write, or both read and write. Same with the standard driver sheet. And the station can be fixed or a string tag, which I just mentioned a moment ago. You also have the scan, always, screen, or auto. And in the standard driver sheet, you can base these on trigger. Now let's go take a look at the always, screen, and auto here. We can set this up for always is default, which means it will scan even if you don't have the tag name on a particular screen. The screen setting, the tag will only be communicated to the PLC when that particular tag is on the screen that is showing at the time. Now what that needs to be paid attention to is if you have tags, for example, that you want to be historically trended or alarmed, then you should probably set that up as always, so that even if you're not on a given screen that has those tags, that they'll be logged in the alarms or trends or whatever information you're looking for. Now, we added recently in 7.0, we added auto. Now, auto, what that will do is it will treat it as if it was a screen type scan until another task needs that tag, for example, an alarm or a trend. And if so, that will then effectively change this to always while the project is running. And it will stay that way while the project is running until the project is stopped. And then it'll revert back to the screen type mode again until it is needed next time you start the project. So auto is kind of an effective, easy way to do it. Always will scan the tag always. Now, if you have all of your tags set up for always, that's going to be very inefficient. So if you have tags that are only used on screens and don't need to be logged, you might want to set those for screen. Well, let's talk a little bit about scaling, min and max, divide and add. In the divide and add fields, what you can do is put a division number here or an addition number here. And for example, if the tag coming from the PLC or the address coming from the PLC, the value coming from that address in the PLC, let's say is 100, and you put a 10 in here, it will do that division, 100 divided by 10, and put the result into this temperature tag. So it can do some of that scaling. It'll also do this add as well. So it'll do both of these. So for example, if you put a 10 in here and a 1 in here, and you had 100 in the PLC, it would do the division by 10, add the 1, and put the result of 11 into that tag. Now, in a similar fashion, you can use this min and max, and you can put a scaling factor in these fields, and that will be represented in all of these individual lines. Or if you put values in these fields, then it takes those line by line, and they take precedence over this per worksheet value. Now, where would you use this? Let's say you have a 12-bit analog value coming in from maybe a 20 milliamp kind of sensor out on a machine somewhere, or some kind of flow meter or something. You might want to put 4095 in here. I'm sorry, in the 0, and then over in the max 4095. And then what you would need to do is go into the properties for that particular tag. So let's go back to the home. We'll go into temperature properties, and here we would put minimum and maximum value. And what this would do is it would scale the 4095 coming from the PLC into be 100%. And the value that would actually show up with coordinating this scale factor with the property maximum, it would make this value here show up as 100%, and it would automatically scale the ranges in between those as well. So that's kind of the differences between the main driver sheet. If you're just starting out and trying to get communications going, maybe you have a simple project, I would recommend putting everything in the main driver sheet. And if you need more flexibility over triggering or what addresses are being read and when they're being read, then you might want to start working with the standard driver sheet. Also, the 600 milliseconds, if you need faster than that, then it would probably be wise to start using standard driver sheets as well. So here, just a quick review, we've got the main driver sheet header. We have those 4 status fields in the disable. And in the standard driver sheet, we have those same 4 status fields, but we also have some triggering features. Now, we'll come back to that in a moment. Let's go talk a little bit about go back to our presentation here and make sure I'm covering some things in order. Let's talk about priority next, and then we'll talk about virtual regroups. So priority, as you may have noticed, there's another little checkbox up here on the standard driver sheet. It's called increase priority. Now, what is tempting is if you want communications to happen faster, it's very tempting to just check that checkbox and you think that, oh, I'm going to increase this priority over everything else, and that'll make this particular worksheet faster. We've actually had people check all the checkboxes in all their standard driver sheets and expect them to happen super fast. Well, what's actually happening is there is a buffer, and this buffer, a queue, if you will, it is not necessarily a first in, first out, where when the driver handles communications to and from the PLC, it's a queue where it's a priority-based queue. So the lowest priority in here is a standard driver sheet where you just have the enable read when idle, and those will be kind of in the bottom queue. And if there's nothing else on top of them, then they'll get serviced and handled accordingly. But you can see these different main driver sheets and the different configurations that you have for the different triggering here will come in the different layers and different priorities of the queue. And the highest priority is when you have the increased priority checkbox checked and all these other situations occurring on the standard driver sheet. They will be on the top, and they will be serviced before all the other priority messages. Well, what happens here is the reason why I'm bringing this up is if you check that checkbox on all your standard driver sheets and you have a lot of them, there's a chance that the system cannot handle them fast enough and never get through all the high priority messages and never get down to the level 2, 3s, and 4s, and you may not be seeing communications happen to these. So if you get a situation where you check that checkbox and you're not seeing the other things update, it's because you've increased the priority of those so much that you can't actually service the other ones. So be cautious of that. If you really want to make the communications happen faster, watch for your triggering as opposed to using the increased priority checkbox. So let's talk a little bit about the virtual regroups and what happens with the main driver sheet. So here, in fact, let me go back in and put the IP address back in here. and I have my PLC running in the background. And let's say I had another, instead of a holding register type address, let's say I had a bit coming in. Let me be its manual mode. And that tag does not exist, so I'm going to create that as a Boolean. And I'm going to copy this address down. And maybe that's coming in from a input style, so a 10,000 style address. So I will do 10,000, maybe that's 10,100 or 110. And now I have pressure, and that's also coming in from this same address, PLC. And now instead of 40,001, let's say maybe I have a few addresses in between 40,010. And get rid of this. I'll keep the scaling in there, that's fine. And now when I save this driver worksheet and I run this, now those, just double check here that yeah, I need to be set here on always for the moment because I haven't put these other addresses on the screen. I just want to make sure everything scans all the time. I'll save that. And when I run this project, what you'll see is I should be communicating with the PLC here in a moment. And let that catch up. There we go. I'm reading values out of the PLC. I'm actually scaled. The value from the PLC is higher than this, and it's doing that scaling function. But what I wanted to bring up is down here in the taskbar, you can actually look at your driver. And in this case, I have the MOTCP driver, and I'm going to right-click on that icon and look at virtual regroups. Now, the virtual regroups that are happening here is I'm reading that individual 10,110 address. You can see it says read item. But what I've done by putting the 40,010 address in is it's actually reading a block. And the reason it does that is it's more efficient to read a block of 10 addresses than it is to do an individual read of those addresses. There's less overhead and less information coming back across the cable, so it is more efficient to do this. So if you really need to start troubleshooting some deep troubleshooting, you can take a look at these virtual regroups and see what's happening when. Sometimes it's a key indicator to maybe switch some of your addresses out of your main driver sheet and put them into standard driver sheets and trigger them more accordingly. What I now want to bring up is the manual. And to show you how you can get to your driver manual, if you go here under Help, go to Communications Drivers. Again, I'm just going to hit the letter M, and that will jump all the way down to the drivers that start with M. I'm going to open up my Modbus TCP driver manual here as an example. And in here, let me change this view to a single page. If we scroll down here, most of the manuals are set up this way where we have some general information, selecting the driver, configuring main driver worksheets, and then standard driver sheets, and then you get into some troubleshooting type information. If we scroll down here, and I'm going to go through this kind of fast, you can see the different PLCs that we tested with. You can see the different reads and writes to the different types of addresses. And again, this is different for every different driver that exists. And we'll scroll down, how to install the driver, anything special you may need, configuring, and then scrolling a little bit farther down, we get to the configuring the driver worksheets. So here's how to do the main driver sheet, and it tells you all the different things that you need to do, what I pretty much covered in the first video. But here's an example of the IP address format. And if you don't know a particular driver very well, it would be wise to take a look at this format, because the different ID addresses and port numbers are going to be different for the different protocols and what you need in there. So take a look at those, and gives you some more examples. And then it goes into standard driver worksheet configuration and talks a little bit about that. Sometimes the standard driver sheet configuration is a little different than the main driver sheet. As we go down, that gives you some examples of what you can read and write to and from. And then we'll go down into the troubleshooting section down here, which the read status and write status fields will report back these error codes. And this is different for different PLCs and protocols. These are often sent back from the protocol itself. So these are sometimes negative numbers, positive numbers, and they're all over ranges. Sometimes you'll get an error code 16 or maybe even a 15. which indicates that we can't connect to the particular PLC. So check maybe using ping to ping a PLC. Make sure that you can get to it on the network. It's very often that the things are not configured right, or you forgot to connect a cable, or you got a bad switch or something of those lines. So this gives you some troubleshooting information. And again, these manuals are all located by going through the help into this communication section. So for example, we can also get to let's say Allen Bradley CIP or Allen Bradley TCP to get to PLC5 family. So let's take a quick look at that one, because this is pretty common. Let me change the view on this. Display somewhat continuous, and we'll scroll down. You can see the different register types that we can get at there, different file types, and we'll scroll down and we'll take a look at some common configurations in here, setting up the main driver sheet, the addressing that you might use there, and scroll down a little bit, and the configuration for main driver sheet, standard driver sheets, and then take a look at the different error codes down here that you might get. You would see that this error code listing is a little bit different than the one for Modbus. So give you a couple examples of those. Then we'll move down to import wizards, and if we were to go and back to our project, it's over here. I can run these different import wizards and bring in tags from exported addresses from the PLC. Close this screen first. Import wizard. There are different import wizards, and depending on your license, you may or may not see all of these. But for example, if I wanted to bring in tags from an RS Logix 5000 database, I can choose here. I can choose to duplicate tag or not allow duplicate tags or replace them. Use the full scope coming back from the PLC. Temporarily, I'm going to put in 127.0.0.1 because I don't have a PLC connected for that. And for this particular import wizard, I need both the CSV file and the L5K file. So what I'm going to do here is go and grab, I think I might actually run out of space here, but I'm going to grab the CSV file, and then I'll grab the L5K file. And then I can choose to put a prefix in front of this. Maybe I have some logic that's very similar or the same in two different PLCs. I could put use a prefix and then put PLC1 in front of all my tag names, and then do this again, and then put it in as PLC2, and then we duplicate those tags, but put a differentiating prefix in front of each of one of those. And when necessary, when suitable for structures and things of that nature, I can create class tags out of that. So I'm going to click on Next, and this tells me that it's too large for this type. That's okay. I'm going to bring in these different addresses, and if you scroll down here, you can see all the different addresses that we'll bring in, and it color codes them depending on what will be happening if there's an error or something along that. I'm going to click Finish, and this will go ahead and bring those in, and it will create the worksheet for me, insert the driver, create the worksheet for me, bring in all those tag names, and thus alleviating a whole bunch of typing on your end. So while this is working, I'm going to cut this little section out of the video, and we'll come back in just a moment. Okay, so that took over a minute or so to come in. I didn't want to make you sit through that, so I cut that part out of the video. So it says that it was finished, and I can click on OK. We can see that has created this driver worksheet here, and it has not only created that for me, but it has brought in all the different tags associated with that. So something else that it has done, if I go back and take a look at my project tags, it has created all of those project tags for me as well. And in some cases, for example, where there's maybe counters, it has created class tags for those. And if I go take a look at my classes, I can see that I have counter, and I have my preset, my accumulated value, my done bit. So you can see that's similar for timer, my preset accumulated value, error, overflow, things of that nature. So what it has done is created those classes for me, so I can get at those individual items within those counters or those timers. So that has done that for me. Now, something that we've added relatively recently into InduSoft Web Studio is tag integration. And rather than creating driver, inserting drivers and creating driver worksheets, we have another way that's a little bit more easy to use, if you will. So what I can do here is I can go up to my project tab, and under the communications icon here, I can go to my tag integration setting. And the tag integration setting, I can click on Add, and of course I have to stop my project and go to Communications, Add. Now here I have a choice of, right now we support TwinCat, CodeAssist, and in version 7.1 is the RSLogix 5000 of the ControlLogix family. Now we have a type called integrated, and an older type called shared. And if you want to use the shared, that's more of a legacy thing, and we encourage you to contact our customer support for that. But what I'm going to cover here is the integration portion, and I might want to call this main controller and give that a name. And now when I add that to my list, it can be either driver or via OPC. I'm going to do driver. I'm going to connect up to my PLC. I'm just going to give it a fake IP address in here, and what CPU slot number it is in. Then I need to point to the L5K file. Now from your RSLogix 5000 software, you can do an export to L5K file and export your PLC project to that Logix 5000 format. That's what the L5K stands for. I'm going to browse, and I'm going to point to that L5K file. And now when I do that and bring this in, now I'm referencing that file directly. So now what I can do, if I go back to one of my screens, let's say, and now put an object with some kind of configuration, maybe it's a bar graph. I'll put a bar graph on the screen, or a rectangle, give it the bar graph animation. Now here, instead of choosing the tag from the list, I have a couple of different choices. I can either right-click on that field and insert the tag, and go right to devices. So here I have my project tags, my system tags, and now I have a new one here for devices. Here's where I named that main controller. So now I can go right into those tags that were brought in from the L5K file and point directly to one of those in this project. So that gives me the capability to do that. Now, what will happen is, even though this is pointing or makes available all these tags, those tags will not be part of your project until you use them in your project. So let's say that there's several hundred tags or several thousand tags, and you've only used 2 or 3. That'll only count 2 or 3 towards your tag count. So that's another orientation, another different way to grab communication values. One other thing that I should mention before we get out, we also have a toolkit available for purchase. If we don't have a particular driver for a particular device that you want, and maybe there's no OPC connection to it, you contact us. Maybe we are interested in writing the driver for you. But if you have a proprietary nature or need, and maybe that's something that we don't have a need for, contact us, and maybe you can purchase our toolkit and develop your own driver interface or your own driver for Intusoft Web Studio. That covers the Driver 2 section. Thank you, and have a great day.